To start with, let's see how many ports and pins ATmega32 provides. This microcontroller have 4 ports named as PA, PB, PC and PD. Among those 4 ports, only PA has ADC on it. Every port has 8 different pins from 0 to 7. To control those pins, data direction registers and port manipulation techniques are used. We have to specify the data directions of every pin we are using, whether it's gonna be an input or an output pin. To program this microcontroller, I am going to use MPLABX IDE software, which is developed by Microchip. To begin with, first of all, create a new project in MPLABX IDE. Select the option Microchip Embedded from Categories and Standalone Project from Projects. Just type in the part number and search for the microcontroller that you are willing to program. Select the compiler type as XC8 to program 8-bit AVR chips. Note that compiler should have to be installed in your system. Provide a suitable project name to your project. Here I am giving the project name as LED blinking. MPLABX IDE will generate multiple files and folders. Go to source folder and add a source file to it. Add a main.c file and select the extension as C. This is a very simple code to toggle the state of a pin. These 3 lines of code is for including header files. xc.h is automatically included by MPLABX IDE. It consists of types, macros and functions specific to the target device. It includes device-specific header files that also provide access to special function registers. AVR IO.h. This header file includes the appropriate IO definitions for the device that has been specified. util/delay.h. To able to use delay in our code, this header file is essential to have. To properly time the machine cycles, a constant clock is required for microcontrollers. This f_cpu macro defines the clock frequency which will be provided to microcontroller with the help of crystal oscillators. Note that many microcontroller has internal oscillators. Here for this example I am using 1 MHz internal oscillator. To define clock frequency, after writing fCPU, write the exact frequency in Hertz which will be in use, followed by an uppercase UL. By doing that, you are telling your C compiler to treat 1 MHz as an unsigned long integer. That is the main function. The actual code goes inside it. This line is responsible for setting the data direction of pins of a port. DDR stands for data direction register, followed by port name which needs to be modified. After that, a bitwise operator OR equal is used. ORing the bits results of change in only that specific bit which is being changed. Use of ORing is a good practice. Finally, the binary value of the port designating the type of pins, where 1 denoting output and 0 denoting input. Microcontrollers do repeated tasks, so an infinite loop is a must to have. All the repeated tasks will be in there. In this case, toggling the state of a pin is the repeated task. These two lines are doing that job. In this line, one-of-a-kind port manipulation technique is used. This is called binary port manipulation technique. Changing the states of port pins, port followed by port name needs to be written. After that, XOR equal operator is used, assigning the port pin states provided. XORing same bits changes the bit to 0 and different bits to 1. Using this technique, pin will change its state in every iteration. Here 0 will set the pin state to low or 0 volt and 1 will set high state at the pin or close to the supply voltage. The _delay_ms library function is used to create a time delay in software. This function takes unsigned integer as parameter. As the name implies, the integer value will be in milliseconds. The other two port manipulation techniques are by providing hexadecimal values and bit shifting. Bit shifting and hex values are more feasible to use. Return is the last task done by any function. Here it is optional because the main function is returning void. Let's compile the code. Hopefully there is no error. Nice, the build is successful. Just copy the hex file path. I am doing the simulation in Proteus. Let's gather the components. Select the VSM model only, otherwise simulation will not work. In the code, I have changed the first bit of PB port, so I am connecting that LED to PB0. Paste the previously copied hex file path here. Also don't forget to set the clock frequency. It should be same as mentioned in the code. The code is executing perfectly. The LED is toggling exactly after 1 second. Let's reduce the delay time and see the result.